Okay, guys, so welcome. This is our last lesson of the week. So we are on section 4.5, day 5, working with exponential and logarithmic equations. And today the type of equations are going to be a little bit different. Still with exponents and logs, but they're going to be literal equations, okay? Now, literal equations involve more than one variable. And so these types of equations really tell us if you know what you're doing. All right, and this is why being able to solve algebraically is so important. You cannot graph these literal equations. You have to solve algebraically. And the SAT, standardized tests, love these kind of questions because it shows us that you actually know the process and that you know what you're doing. However, the goal in a literal equation is still to get the desired variable alone. Okay? So just a fun little reminder here for you guys. Don't freak out. All right? Just because there's more than one variable, you're still going to solve the same way. Okay? Don't just look at the problem and go crazy. All right? We're going to walk through the steps here and figure out how to solve these. So, like I said, just a little reminder, don't freak out. We're going to solve the same way. So just like in any equation, you add or subtract first, then you multiply or divide to get that variable alone. To cancel out fractions, multiply every term on both sides by the denominator. Okay, that's how we get rid of any fractions. To cancel out exponents, that's when we use log. And to cancel out e, we use natural log, which remember is ln. Okay? So here are just some tips for solving literal equations. We're going to go through 4 different problems, and that's it. So here's my first one. Okay, guys? Solve for the indicated variable in terms of the remaining symbols. Use natural log for solving exponential equations. So I have a equals p times e to the rt, and I want to solve for r. So that means my goal is to get the variable r alone. All right? So there's nothing for me to add or subtract. So then I see if there's something I can multiply or divide. The e and the exponents are glued together because they're exponents. But I can divide both sides by p. Okay? So on the right, my p's cancel out. And now I have a over p equals e to the power of RT. Now, if I'm trying to get this R alone, how do I get it out of the exponent? This is when I rewrite this in log form. So I'm going to take log. Remember, the base of the exponent becomes the base of my log. So log base e of whatever's over here by itself. So log base e of a divided by p equals, and then I put the exponent over here, r times t. So I'm almost done. Okay, guys? If I want to get r alone, I just divide both sides by t. Notice how I'm going to write this. The log of e, the log base e, of a divided by p divided by t equals r. Now let's clean this up a little bit. Log base e, remember this is ln, and that's what they said in our directions. They want natural log. So ln of AP, instead of saying divided by t, we can also say times 1 over t. And that's how it's going to show up on the test, so that's why I want you to get familiar with that, equals r. So here is my final answer, okay, guys? It's just a matter of rewriting our work into a different format. So ln of a divided by p times 1 over t equals r. 1 out of 4 problems done. Let's go to the second one. All right. Again, we want to solve for the indicated variable. We want to use natural log. In this case, we are solving for I. So that means I want to get I alone. Okay? There's nothing for me to add or subtract. So the first thing I'm going to do is divide both sides by 10 to, again, start trying to get that I alone. So when I divide both sides by 10, I have d divided by 10 equals the log of I over I sub 0. Now remember, if you see that word log, my default base is 10, even if they're not showing it to you. In order to get rid of that log, I'm going to rewrite this in exponential form. So that's going to look like 10, because remember the base of my log is the base of the exponent. Whatever I have over here on the other side of the equal sign becomes my exponent. So 10 to the power of d divided by 10 equals whatever I was taking the log of goes on the other side of my equal sign. So equals I over I sub 0. Now if I want to get the I alone, how can I get rid of that I sub 0? Just multiply both sides by I sub 0. So here on the right, they cancel out. And so my final answer is going to be 10 to the power of d divided by 10 times I sub 0 equals I. So that's it. Okay, guys, there's my final answer. I hope you're realizing, yes, these are a little confusing because of all the variables, all the letters, but the process is still the same. Okay, guys, this is very doable. You guys can make this happen. We're halfway done, okay? 2 of our examples are done. We have 2 more. So here we go. All right, example number 65. Solve for the indicated variable in terms of the remaining symbol. Use natural log for solving exponential equations, okay? So we're trying to solve for I, so again, to get that I alone. This is similar to the last problem, but we have an extra step because there is something that I can add or subtract. I can subtract this 6 from both sides. So that's going to be my first step. M minus 6 equals negative 2.5 log of I over I sub 0. So now from here, I see if there's anything I can add or divide. I can divide that negative 2.5. So I divide both sides by negative 2.5. So now on the left, I have m minus 6 divided by negative 2.5 equals log of I over I sub 0. Remember the default base that they're not showing us is base 10. Okay, so I'm going to go ahead and rewrite this in exponential form. So I'm going to take 10 as the base, because if it's the base of the log, it becomes the base of the exponent. Whatever is here on this side becomes the exponent. So I'm going to have 10 to the power of m minus 6 divided by negative 2.5 equals, and then whatever we were taking the log of is what goes on the other side of the equal sign. I over I sub 0. So I know it might look a little confusing, but again, we're just following all the steps. Don't worry about what it looks like, just worry that you're following the algebraic steps. To get this I alone, I multiply by I sub 0 to cross that out. So that means I have to multiply the other side by I sub 0. So this leaves my final answer as 10 to the power of m minus 6 divided by negative 2.5 times I sub 0 equals I. And there's my final answer. Okay, guys? Again, just following our steps. One more problem here. Our last one, number 67. Okay, guys? Solve for the indicated variable, use natural log. So again, now we're solving for t, and you guys see there is a lot going on here. So the first thing we want to do is see if there's anything we can add or subtract. There is not. So then we go to multiply or divide. I can get rid of this divided by r by multiplying. So let's multiply both sides by r to get rid of that fraction. So now I have I times r equals e times 1 minus e to the negative RT divided by L. All right, now to get rid of this e, I can divide both sides by e. So now I have IR divided by e equals 1 minus e to the negative RT divided by L. All right, now we have a different problem because now there is something I can add or subtract. Now I can subtract that 1 from both sides. So now I have IR divided by e minus 1 equals negative e to the negative RT divided by L. Now keep in mind in front of this e is an invisible negative 1. So again, that is something that we want to get rid of. So to get rid of that negative 1, I'm going to divide both sides by negative 1. So here on the right, they cancel out. On the left, make sure you divide everything by negative 1. Okay? So that means that we're going to end up with negative IR over E plus 1, because negative 1 divided by negative 1 gives me a positive. And on the right, I just have E to the negative RT divided by L. So I know it's a lot, guys, but you're doing great sticking with me. Okay? From here, now I'm going to rewrite in logarithmic form. Okay? So I'm going to take log. Remember, the base of my exponent becomes the base of my log. So log base e. Whatever is on this side of the equal sign is what I'm taking the log of. So log base e of 1 minus IR over e. I just switched the order of those terms, okay guys, so that we would have the whole number first. And then equals, I put my exponent over here, negative RT divided by L. All right, so there's a lot going on, but we are trying to solve for t, so I want to get this t over here alone. So how do I get rid of that L? I'm going to multiply both sides by L, okay? Notice log base e is just natural log, so I'm going to put ln of 1 minus IR over e times L equals negative RT. We're almost there, guys. One more step. To get that t alone, I'm just going to divide both sides by negative r. So my final answer, guys, is going to be t equals ln of 1 minus IR over e times L over negative r. So here in the bottom right, this is your final answer. And I know there were several steps to that, okay guys, but just keep following that algebra, go back in, see what I did from the beginning if you need to, all right? And that wraps up our lesson for today. Okay, here's your homework. It's only 4 problems. I know these are tricky, but they're going to be very similar to what we just did. So page 449 to 450 in the textbook. Make sure you upload those into Google Classroom. And if you guys have any questions, make sure you put those in the comments in Google Classroom. Okay, guys? After this, we only have one more lesson. All right? So thanks for joining me for this one, and I will see you guys for the last lesson of the year next time.